So I will be focusing on getting data from VCGI. I'm going to also talk a little bit about some of the things you need to be keeping in mind as you're getting data, as you're looking for data, as you're using data from a variety of sources. I am going to talk about bringing that data. We are going to be focused on QGIS. I'm going to be opening that up in just a second, and bringing different types of data into QGIS. So not only shape files and data that's already in a GIS format, but also tabular data and GPS data and data that has that long in it, as opposed to data that's just tabular and that you would want to join to existing data. So we're going to go through a few different ways of bringing that data in. So if we were looking for some data here at VCGI, we would click on the Data and Imagery tab over on the left, and you'll see that there are a number of different subsections within here, but right in the main section there are two different search engines. One is the theme search engine, which is basically just categories of data. I could pick one of these and click on Go, and then I would get a search results table. There's a keyword search where I put in a word and it searches, and I always have to warn people that this is not like a Google search. It's not an incredibly robust search engine. It's if we have thought to put the word that you're typing in its exact spelling in a certain field in a database, then it'll work out, and if we haven't, then it won't. So don't give up just because if that keyword search doesn't result in what you're looking for. If you look at these categories and you're not really sure which category you should be looking in for your data of interest, you could also look over here on the left. There's theme index, which is actually just a breakdown of those themes into subcategories. So you'll see that within each of these now there's a bunch of different options. And again, any of these, no matter how you search, when you click when you get to the final step, what you're going to get is a search results table, and you'll get the name of the data layer, a very brief description of the data layer, the data manager, and then a click to more info, which is really the beginnings of looking at the metadata or information about that particular data layer. So this is what we call metadata light. It gives you some of the basic information. This is point data. Its coordinate system is state plane meters. It gives you a link to the data manager, so you can actually contact someone if that link is still up to date, which most of the time it is. It tells you how old the data is, and when it was actually posted. Tells us that it is statewide. And then if we want to get into the details of the data, we do link directly to the full metadata. In this case, you can see we have a few different format options. This is going to, I think, FGDC Plus by default. We could go to FGDC Classic. So these are all just ways to present the same information, just sort of visually, whichever works for you. And we'll talk a little bit more about that later. So you'll see two columns for download options. One is just download and one is custom download. In this case, there is no custom download option for this particular data layer. And actually, I'm just going to go back and do a different data layer. Not because it has a custom download option. So here is some dams data showing locations for dams around the state. Again, this is a point data layer. And if I click on this, it just, because it's statewide, it just downloads it, and it shows up right here on my desktop, and there it is. And I'm going to put it in my data folder. All right, you can see I've already done this, so this is where I would put it. And then I would go in here, and here's my zip file. So it came in as a zip file, and I would just right-click, extract all, and tell it where I want to put it, and it would do that process. And then when I open up, there's the data. And, by the way, the metadata. So in these pre-zipped files, at our website at least, you will get the metadata wrapped up in there as well, in both HTML and text format. Whoops. All right. So that's the basic process for downloading data for finding and downloading data. as you see, we have this custom data download, which we're not really looking at. So let me just show you what's involved with that. So if I was looking for contours data, for instance, some of our lovely new 2-foot contours that are available because of the LiDAR data that has been collected in Vermont, I would click on Custom Download because perhaps I want a very specific area. I don't want to have to download, well, this data actually isn't available as whole state. I'll show you the other way that it's available. So this is showing us the availability of this 2-foot contour data. The pink areas are where it's available. Notice that the very first thing in this custom data download tool is dataset must be visible before you can extract it. So that doesn't mean that the pink has to be visible. It means the data itself. So let's just zoom way in. This data is quite dense, so we have to be pretty zoomed in before we see anything. Let's hope it redraws. Come on. All right, well, we may or may not do this for real. This is always the danger of the live demo. So if I was actually seeing contours, I would move on to my step 2, which is defining my area to clip. And let me just point out again that I am not actually ready to download because I'm doesn't seem to want to redraw. So I would create my coverage extent. You noticed when I did that, it actually told me to double-click in order to finish my extent. And then the final step is simply choosing what format I would like the data to be in, shapefile or file geodatabase. And then I would click Extract Data. I'd have another zip file downloaded onto my computer, put it where I want it to be, and unzip it. If, on the other hand, I didn't want to do the custom download, like today, if it wasn't working for me for some reason, maybe my internet connection is a little too slow, I would click on the regular download, and for this data, because it is so dense, it does not give me the option of downloading the whole thing. Instead, it breaks it up into tiles, which are conveniently cryptically named, and in order to figure out which tile I want, I need to go to this index map, and you will always see an index map at the top of that list, and zoom in until I can figure out which tile I'm interested in, perhaps 0417. Go back a step, and then I'm looking in the middle here of the name of each one for 0417. And there's 0417. So if I was interested in that contour data, this is the tile that I would click on to download. You will see that this same process is how you would download orthophotos. So here's some new orthophoto data we recently posted. Oh, we don't have the custom download for that yet. Hold on. Let's instead go to some previous year's data. So this data, you can see the coverage is Chittenden County and part of central Vermont. And again, if I just zoom right in for a while, I believe it will eventually draw me some imagery. Not that there's much to see up here, but I should get imagery eventually. There we go. All right, so this is the point at which I can actually define my area to download. And in the case of imagery, we have different options. You can do a JPEG 2000, an ERDAS Imagine file, IMG, a TIFF, or a file geodatabase. And again, same process. I would just choose this and then click on Extract, and I'd have a zip file to save, move where I want it to be, and then extract. All right, so there's a few different kinds of data and different ways that you can get at the data at our website. Okay. I'm just going to take a moment to look back into this metadata. So here's the dams metadata, the data that I recently downloaded. I just want to point out that some of the information that you'll find in the data, and this is important because when you're getting data from different sources, you really do need to think about to understand the data in order to use it appropriately. So one thing that you're going to look for and find are things like the format of the data. So if you're handed some data and maybe verbally you're not really given much information, but there is metadata, you can look for things like in the distribution information section, things like format specification. So here it says that this is in fact a shapefile, which is helpful to use. Another thing that you might want to know about your information is the spatial reference information. Things like State Plane Coordinate System 1983, which is referring to the horizontal datum, the North American datum of 1983. It's not only State Plane Coordinate System, but specifically Vermont, which is only indicated by this code right here, 4400. These are important things to know in case you have any issues getting your data to match up with other data. In the case of all the data that you download from VCGI, there's actually going to be a PRJ file associated with any shape files. That's a projection file, and it's sort of like a translation file. It says what the coordinate system of the data is, and it allows the software to interpret it appropriately, and which, as I said, really only matters when you start getting different types of data together. Actually, there are a couple other reasons that matters, so we'll talk about that as we open QGIS. All right, I think, before I go on to QGIS, I want to just go to another state data warehouse, GIS data warehouse, which is in New Hampshire. It's called Granite, and it's based at UNH. So Granite is, at least in the sense of being a statewide GIS clearinghouse, the equivalent of VCGI. And as you can see, it's different from state to state. VCGI is currently a public nonprofit. Granite is part of UNH. Different states have different setups. We're going to go to this download free data download. We're going to use the Granite Data Discovery tool to search and find something. And I am going to type in town, because I want to find town boundary data. So here's New Hampshire political boundaries at a 1 to 24,000 scale. There's a link to the metadata, and there's also a couple of options at Granite in terms of what format we get it. I do want a shapefile, so I'm going to keep that. Download now, and once again, I automatically get this statewide download onto my computer, and I would put that right here and right into my data folder. And in fact, I have a Granite folder where I've downloaded it, and this is obviously data that I downloaded previously, and I have already extracted it. Now this data actually has both line data and polygon data. So it has the town boundaries represented as lines as one shapefile, and also as polygons in another shapefile. And we would open up the metadata, which is here, to, I think it's right in the summary, where it says what they're called, what each one is called. And I probably shouldn't look for it right now because it took me a second earlier. So we won't worry about that, but it is in there. So there's just a quick example of how another state does their data download system. If you do multiple data from multiple states, you'll see there's lots of options. Well, every state does it differently. All right, so we're going to go ahead and open up QGIS. So you can open QGIS in a number of different ways. One way is from your start menu over here. Go to all programs, QGIS. Here's the most recent version that I downloaded a month or so ago. And if you've downloaded QGIS and you're confused by the fact that there's all these different things that kind of get downloaded with it, I can't really say too much about why that is, except that it's got many options for people who know how to take advantage of them. But desktop, QGIS Desktop is the one that is actually the software. Browser is a way to look at files and I think maybe do things to files, but desktop is the one that is just opening up the mapping software. Hopefully it's not going to open slower just because I'm doing it live. All right, so here's QGIS. We're going to start bringing data into it, but before I get started, I always make a point of setting my project properties. So I click on Project, go to Project Properties, in order to enable on-the-fly CRS transformation. CRS stands for Coordinate Reference System. And if anybody's unfamiliar with in general what that means, my very quick definition or explanation is that when you are trying to create a flat map on a flat piece of paper or flat representation from information that is inherently curved, because from the surface of the Earth, we do something called project it. And there's a mathematical way to project from a curved surface to a flat surface, and then we have to have some kind of a system for designating where different things on that map are, and we use a coordinate system, which is just an XY grid. And in this case, what I'm going to set this to is the Vermont State Plane Coordinate System. Again, it's the North American Datum 83, which is just a model for how the world is shaped. And in the case of Vermont, the units that are used in this grid are meters. And that's important because in a few cases you'll see that it's not always automatically one or the other, meters or feet. New Hampshire, you can find both feet and meters. If we look down here, you'll see there's a New Hampshire that doesn't say anything, and then there's a New Hampshire that says feet US. And their state standard actually is feet, so the data you get from Granite will be in feet. Whereas in Vermont, most sources, particularly state sources of data, will be in meters. If you get data from surveyors, foresters, there is the chance that that could be different, which is one of the reasons it's important to know something about the data you're getting. So I'm setting the project to meters, and I'm enabling on-the-fly CRS transformation, which means if I bring in data from a source that, or if I bring in data that is a different projection and or coordinate system, it will do that on-the-fly transformation. It will essentially do a mathematical transformation to make it fit in the Vermont State Plane system. And it's just math, but the software knows how to do it as long as it has the information it needs. All right, so now I've done that, I'm going to put in some town boundary data. So, oops. So to add data to my blank map, the first thing I'm going to do is click on Add Vector Layer. Notice if you haven't used QGIS much that you have all these different ways to add data, and if you just hover over them for a moment, they will a little label will pop up. We're going to use a few different ways today. I never mess with this section up here, source type. There may very well be situations where one should, but I have not found it to be the case in my basic use of QGIS. So I am going to go into here. I want to point out that when you do go to add vector data, by default, this right here, this little area down here that's about the file format it's going to look for, is set to Esri shapefile. Pretty sure it was defaulted that way when I installed the software. You can, however, change this. You can change it to all files if you're looking for a different type of data, as we will be doing a little bit later. You can set it to, as you can see, there's a bunch of different options. So I'm going to leave it shapefile for now because that is what I'm looking for. We'll change that later. So what I'm putting in here is a town boundary data layer that I had previously downloaded to my computer. So there's Vermont. I'm now going to add the data that we downloaded earlier from Granite, and I'll just mention that in the past, when I did this part of this little training, I was trying to make the point that you really have to set your project properties to Vermont State Plane meters ahead of time, because otherwise your data won't line up. But I found out today that I can't make that point anymore because QGIS seems to have gotten smart enough that it really does the on-the-fly thing automatically, as long as there's a projection file. So both of these data layers have projection files which indicate I'm Vermont State Plane meters, I'm New Hampshire State Plane feet, and that allows the software to figure out what to do with it. However, if you don't set your project properties to a certain coordinate system ahead of time, it doesn't really know. Well, what it does is it creates a user, sort of a custom coordinate system, and I'm not really sure what it's doing when it creates that custom system. It may be that it's setting the units, for instance, to whatever the first data layer you brought in was in. But I would just suggest that it's still important to set your project properties, because it's going to ensure that things like, if we look down at the bottom here, your coordinates, your scale, and then also your ability to measure are all going to be accurate. So, like I said, I'm not sure exactly what it's doing in terms of that user-created custom coordinate system when it brings them together, but it does. You don't have to worry about things not matching up as long as you have a projection file. And if you don't have a projection file, it will just ask you what the coordinate system is for that data layer. Okay. So here oh look, my printout didn't print out. So here we have our two parcel data layers. We are also going to bring in so actually this is, all right, so this is, our first step is simply to have downloaded this data and brought it in and to address the coordinate system issue. So this is shapefile data. Another option, another type of data that we can, or another way that we can bring in information to our map actually, is through what's called a web map service. So adding a web map service is only possible if you have an internet connection, and in particular you probably only want to do this if you have a good internet connection, meaning a fairly fast one. You would never do this with dial-up. If you know you have particularly slow DSL, you can try it, but be prepared for it not to work that well. The idea here is that through the internet, your software is connecting to a server somewhere else that is providing this service. That is, in this case, because we're talking about a web map service, it is essentially a map rather than just a pure data layer. And it's already symbolized, and there's still quite a bit of flexibility to it, but there's not as much as there would be if you had a data layer on your local computer. So if I was doing this for the first time, I'd go back to VCGI's web page. Notice that in the Data and Imagery section, we have a Web Services section. There's a little bit of how-to information here, and then there's a whole lot of services listed. And an example of something that's really convenient to use as a service is imagery, so orthophotos and the like. So the first thing I'm going to show is best of color imagery cached Vermont State Plane meters. So best of, in the case of VCGI's services, means that at different zoom levels you're actually potentially going to be looking at different imagery. So we have created a pre-cached series of maps at different levels, different zoom levels, that represent the best option for that location, that zoom level, etc. Now cache refers to the fact that these are pre-made images, pre-made maps at these different levels. So a bunch of time went into creating them, and that basically makes it happen a lot faster, the performance be a lot faster within QGIS. It's not literally creating the map as you're asking it to. It's really just pulling up a pre-made image. In order to connect to this service, when I'm using QGIS, and notice my two options here are ArcGIS 10X layer file, or ArcGIS 9.3 or lower, and open source. So these are the two different options for connecting. If I was using ArcGIS 10X, I would click on this. Because I'm using QGIS, I'm actually going to right-click on the second option and choose Copy Link Address. Then I just have to go back to QGIS, right-click and paste, and you can see that this is just a URL. That's located at our server, our map server. I can give it a name. I can ignore all the rest of this because there's no username or password for our services. At least they're open. Don't need to do any of this. So now it's listed here, and all I did was just add it to a list of previous services that I've connected to previously. But that's the new one that I just put in here. I click Connect. It makes the connection, so as long as it lists something here, it means, yep, that worked. It made a connection. And now to actually add it to the map, I highlight it. I'm going to make sure to change my image encoding to PNG because I've noticed in the past that if you leave it TIFF, it really doesn't work properly. JPEG or PNG both seem to work fine. And down here I have the option of either leaving this as the name or giving it a slightly easier to read name. And then I just click Add, and you can see that it adds it to my list, and there it is. So at this zoomed out level, it's not taking an hour to draw just because it's statewide imagery. And yet when I zoom in quite a bit, it does take a little bit longer to draw because this is higher resolution. And as we zoom in, you'll see that we still have quite high resolution data as you zoom in and zoom in. So this is at about a 1 to 7,500 scale. And again, it's going to vary, in the case of our data at least, it's going to vary a little bit as you move around the state, what's available, because some areas of the state have higher resolution imagery than other areas, especially in the color imagery. Okay. So that's, oh, I know what else I want to say about adding. So this is adding imagery. Another option, if we go back to our list at the BCGI website, we have imagery services and we have map services. And in the map services list, we have things like the parcel boundaries for the state. So if you just want to add parcel boundaries, you can have that as a service coming in. We also have contours, another data layer that's, you know, as we saw earlier, we tile it because it's kind of heavy. It has a lot of data in a small area, so it's nice to be able to add that with a service. USGS topo maps, you don't have to download all the individual maps in order to get them into your map. Hillshade. And then the other thing we have is a base map. And the base map in our case is not talking about orthophotos, it's actually talking about a map that has lots of layers on it. And since I've already connected to it, I'm just going to go back to QGIS and show you. So here's the base map. And remember, each time you choose something, you have to actively connect. And you can see that this has a bunch of different data layers. Now, one of the few shortcomings of QGIS, in my opinion, is that if I were to say, yes, I want the whole base map, you'll notice that down here at the bottom where it says layer name and 38 layers have been selected, this literally is what it will try to show as a layer name. In our table of contents, it'll just list all of these separated by slashes. And unfortunately, it also doesn't give us the ability to manipulate the layers separately. It just lumps them all together. It works, but you can't manage it as well as you can in ArcGIS, if we were to bring this service into ArcGIS. So I just urge caution. If you have access to or want to use something like our base map, just be a little bit careful. I think it's most useful probably to add simply 1 or 2 layers from this base map. So like adding all of the roads is helpful because if we I'm just going to get rid of this because it's still too many things. So I'm just going to write roads. I've got a PNG. So again, it's going to take a second to draw it. It's sending a request to our server and then getting it back. So the symbology still isn't ideal in QGIS. It looks a lot better if this was in ArcGIS, but it works. And the nice thing is that all the preset things like when different roads show up at different zoom levels does work, which means if we zoom out to statewide, we don't just see a mass of roads, we only see the interstates because that's what's set to show at this level. Whereas if we zoom right in, we will see a more appropriate level of road network for that zoom level. So it's a convenient way to add certain layers so that you don't have to symbolize them all, perhaps, or if it's just a visual reference for you, it helps to put that information in there. Okay, so that's services. Now, I'm not going to get into all the other types of services like web feature services because I don't honestly know that much about them, and I haven't used them in QGIS in particular. I just wanted to mention web map services since we have quite a few available. Adding raster data is, I think I'm not going to bother with it. It's pretty similar to adding vector data. It's just that you're adding a raster image instead. And adding raster layer in this case would mean you have that saved on a drive that's accessible to you. So I think I'm going to go on to adding a delimited text layer. So a delimited text file is obviously a text file. It's really originally a table of information, and delimited refers to the fact that we've taken something like a spreadsheet and we've saved it as a text file, and its columns and rows are delimited by some type of thing like a comma, or in the case of the data that I'm interested in, a tab. So I'm actually going to change this. All right, let's browse to where it is. Here it is. So I got some data years ago from a USGS website, I think, that gave the lat-long coordinates of New Hampshire dams. So I'm going to point at that CSV file. So it's a comma separated values is what CSV stands for. And then there's a bunch of settings on here that are important. Now actually it's interesting. It was able to look at the file and figure out that tab was the proper delimiter. But let's just pretend for a second it didn't know that. And by, I was trying to remember perhaps how it's delimited, and I thought, well, is it comma? But nice little features that it shows you what things look like if you choose that. And I was like, that doesn't look right. If I do tab, it does look right. Take a look at it. So obviously separating the data out correctly. You can also see that by default, well, I don't think it's by default, I think it's because it looked at the file. First record has field names is correct because you can see that here they are. And if we were to take that away, we'd just have no field names, and this first row would be what are obviously field names. So, so most of the settings you'll be able to figure out when you've got it set correctly because it'll look right down here, which is kind of nice. And then the final very important setting is this X field, Y field. So these fields are named in a way that, again, I think the software is able to sort of figure it out, or they're in the right order or something, because the longitude, which is in decimal degrees, and the latitude, that's what the lon and lat are in here, are indeed assigned to the right fields, the X distance or X direction and the Y direction. If you can remember what longitude and latitude are, which honestly I never can, but this is correct. Now, it doesn't know by default what my coordinates are. So my coordinates are longitude and latitude, but it doesn't know that by default, or it doesn't automatically know that. So I actually have to tell it. All right, so my tabular data is representing coordinates that are in fact latitude, longitude, which in the world of GIS means WGS 84, World Geographic System 84. So I'm going to choose that. So keep in mind that what it's asking for here is not what your project is set to, but what this new data that you're bringing in is actually measuring distance and location with. We're using a system called WGS 84. Now the first thing you're going to notice is that we don't see anything, and that's because we're right now zoomed in New Hampshire, and this is obviously, or sorry, zoomed into Vermont, and this is obviously New Hampshire data. So I'm going to right-click on this layer, which has indeed shown up over here, and I'm going to zoom to layer. Now the next thing we notice is that this doesn't quite look right, and what we're looking at is a little cluster of dots over here on the left, and then another dot way over here in the far right. And if we just zoom in on Vermont and New Hampshire again, we'll see that, all right, most of the dots showed up here, so that's about right. If we open up the attribute table for this data, so this is the actual table that we just brought in, just becomes the attribute table. And you can see there's lat longs here. Well, if we click on the column header, it puts them in order, numeric order, and you can see that there is this one point that is 0, 0. Well, 0, 0 is obviously not in New Hampshire. And actually, if we zoom to selected, you will see that this is that outlier point out in the middle of nowhere. So it's just an example of the fact that data is not perfect. And in this case, you would probably want to clean up this data before you used it. There's actually another outlier down here in Massachusetts somewhere as well that must either got in here by mistake or just has a number transposed or incorrect. But most of them have worked out just fine. So we just took a table of data that had the geographic information in it, but wasn't actually a GIS data layer, brought it in as this delimited file, and the software is able to say, oh, okay, I get that. I can transform that into essentially Vermont state plane meters and put everything in the right place. I might as well throw the Vermont dam data on there as well since we have it. There's our Vermont dams. The other thing that I want to do, and I'm going to just turn off the imagery in the roads for a minute, is bring in tabular data that doesn't have an inherent geospatial component. And what I mean by that is it doesn't have coordinates associated with it. It is actually inherently geospatial, but it doesn't in the table have the information the software needs to simply slap it on a map. But what it does have is information that links it to some geospatial data that we already have. So in this case, we have town boundary data for Vermont that includes the name of the town. So that's in the attribute data. We also have the FIP6 number, but in this case, we're going to take advantage of the town name. And what we're going to do is join some tabular data to this existing geospatial data. So I am going to add in an additional little bit of data that is a table, or actually it's another text file. Now this is the point where when I first was practicing this earlier today, I was like, oh, where did my little table go? And I realized I have this set just looking for shape files right now, and I need to change it to all files. Oops, I'm still in the wrong. Just do that one more time. I was in the wrong place as well. So here all I can see is shape files. If I go to all files, I will find my parcel data status table. So I originally created an Excel spreadsheet out of a database that I have, and then I saved that as a CSV file. So it's a text file that's comma delimited. So that's actually the table that I want to bring in, and if you can see over here, here it is in my list. So bringing it in doesn't add anything visually because it's just it's a text file. It can't be interpreted as part of our map. But what we can do with it is go to our town boundary data layer, go into properties. So here's the properties for, oh, it was already in there because I've done it. So wherever it starts out, in here you're going to put it onto the join area of your properties. we're going to click on this green plus sign to say I want to create a new join. There's not currently a join here, so we need to create a new one. So by join layer, it means what's the layer that you've brought in that you want to join to this data layer. So I want to join my parcel data status table. I need to make sure it's looking at the right field name in the table. So these are the column headers in the table. I'm going to pick the right one. And then I need to pick the right target field in this data layer, meaning the town boundary data layer. So I need to pick town name. Now, these two fields do not have to have the same name. They can be named whatever you want them to be named, but you need to know what's in them and the content of those 2 fields. And again, these are in 2 different, one is in a text-based table and the other is in our GIS data. The content of them needs to match in terms of the type of content. In other words, is it text or is it numeric? And then in order for the join to work, you do actually have to have some records that actually match if you want to end up with something joining. All right, so I've indicated everything correctly. I'm going to say, okay, there it is. And then I can say apply. Okay. Nothing much happens because all we've done or tried to do is attach more attribute data to our town boundary layer. So let's see if it worked. We open up our attribute table. Now remember, originally all this had was FIP6, town name, county, area, and length. And now we have some additional columns in our additional attributes, basically, in our table. And the one that is of particular interest to me is update year. So generally when I actually do this particular join fairly often because I like to represent parcel data status. And this represents the year of the parcel data that we know of that exists for each town. Some of them are missing data, which is the 9998. Actually, I think that's unknown. And then some are indicating the various years of the data as far as we know. So now that I have this information joined to the town boundary data, I can actually change the symbology of my town boundary data. I might assign it different colors for different years or different year ranges. I might just give it a different color if it's above a certain year or below a certain year. If you're interested in that, come join our webinar on February 25th when I'll be talking about using attribute data to change symbology and labels. Okay. I think we're going to do GPS next. All right, so we have found data, just regular shapefile data, vector data, brought it in. We've brought in some web map services. We have brought in tabular data that has geospatial information, it has coordinate information in it, and we've also figured out how to connect some tabular information to existing geospatial through a join. So that's an attribute join. Oops. I keep forgetting about those outlier points. All right, so the next thing we're going to do, I have sitting next to me, which you guys can't see, a cheap GPS. It's a Garmin GPS 60. So I'm going to turn it on. I'm going to also turn off the GPS part because I'm really just using this for some data that got saved on it probably last summer. There's just a few points on here. So my Garmin GPS 60, it has a port in the back where I can plug a cable into it, and then I can plug it into my computer via a USB port. Oh, I'll find out if I shouldn't have done that yet. But so QGIS conveniently gives us a plugin that allows us to directly download data from a GPS. The first thing that you will want to do is check your plugin. So plugins and then manage, just do that one more time, manage and install plugins. There are a bunch of plugins that come with QGIS. You don't have to go out and search for these. There are plenty more that you can go out and search for, but many of the ones that it actually comes with are not turned on necessarily when you first install it. So all you have to do is come in here and find the one that you're interested in, put a little X in the box next to it, and you'll be able to turn it on. So I am checking for GPS tools, And here it is right here, and it is indeed already turned on. It also shows you what the icon looks like, which can be helpful. So I'm going to look all the way over to the right. Notice that there are actually two icons related to GPS, and I want to be careful not to choose the one that says Create New GPX Layer. At least that's not what I'm doing right now, today. That might be something you're interested in doing. I actually want the one that just says GPS Tools. And when I turn that on, notice that there are a few different options, these tabs across the top, but the one that I want is Download from GPS. I want to make sure it says Garmin Serial. Not sure that I've ever seen any other options there, but just I know that works. We want to make sure our port is set to USB, at least in my case, since I am plugging my GPS in with a USB port. I am indeed going to download waypoints. If I could actually try it. I can't remember right now whether I have routes or tracks on here, but waypoints is what we're going to do right now. I'm not really sure why it makes you name it right here, since you end up naming it about at least twice. So I'm just going to call this points. I don't think this name matters. The output file name does matter, because this is, you can see I've already done this. This is the name of the GPX file that you're creating. And notice you don't have any options in terms of format. This is just going to be a GPX file. And good, it made the nice beeping noise. That means that it worked. And you can see, where is it? Points. Not sure why it puts it there. I'm going to put it up at the top just so you can see it. So at the very top of my list of data layers, we have points. And if maybe I should turn off some of my other points. Hold on. Turn off my Vermont points at least. And if I zoom to layer, so there are my points. Oh, and I can also turn this back on, just because it'll give us a little bit of context. So I think that we are at VTC. I think that's where these were collected. I'm just going to change the color so you can all see them. Okay, so those red stars are the points that were collected, and this is, I'm pretty sure that we're at the VTC campus, and I did a training there last summer, so somebody collected these points on their GPS. So all I did was plug in my GPS, use the GPS tools to say I want to download it, and it saves it. Now keep in mind, this is not a shapefile right here. This is a GPX file, but I can save it as a shapefile or one of a number of other different types of files. Once again, I can browse here, name it, save it as a shapefile. And I want to point out that it gives you the option for setting the CRS, and I want to make a point of setting it to project CRS. If I left it layer CRS, the projection coordinate system, or the coordinate system, would be WGS 84, because that's what this is by default, the GPS data. But I want it to be Vermont State Plain, so I'm going to do project CRS. And then I just click OK, and it's going to add it in as webinars 2. So notice those red stars, and if I get rid of them, I still have my newly created shapefile of red dots. And the benefit of this, and I'm just going to very quickly because I'm running out of time, the benefit of turning it into a shapefile is that we can now edit it. So this is the last thing I want to say about kind of manipulating your data. What you can do to transform data is I can edit this data. So I highlight it, click on the toggle edit tool, and I can now edit the attribute table. So you can see this is by default what came with these points from the GPX. There were some names that were put in. I can now edit the attributes. I can also move features, so I can edit the the location of the features, and I do that by just getting this little crosshair thing on the feature, and then, oh, it just takes too long to draw. I don't know if you can tell that here. I'll move this right over here. Okay, so you can see that I've moved that. And then when I'm done, I just turn off the editing, the toggle editing, and notice that at this point I can say I want to either save the changes I made or discard them. And if I say discard, when it redraws, you'll see that point went back to where it started over here. All right, so that's my quick editing, and should I mention very briefly that you can also very simply create new data. So in the same add data list of options, there's create new shapefile, or actually it's create new, well, it can be either a spatial light layer, which again I haven't worked with so I can't comment on that, or a shapefile, and you get to decide what it is, what its CRS is, what its name is, or sorry, then you can define attributes that you want to have in the attribute table, type, length, names of those attributes. And once you've done that, it'll show up in your list of, in your table of contents. Nothing will be on your screen because you haven't added anything to it yet. And at that point, you'll start adding features to it. Okay, I think I need to stop talking and see if there are any questions. So that is the end of my formal presentation. I'm sorry that I've gone a little bit later than I meant to. And if you have questions and if you can stick around to add them, then I would be happy to answer them. And maybe I will go ahead and create that new data just to demonstrate that. So let's say I want to make a polygon. I want it to be Vermont. I'm going to have an attribute called name. Probably don't need it to be quite that long. And I have to save it. So this is the new shapefile that I'm making. So you can see it listed over here, and now I have to actually edit it. So I have to highlight it, click Edit. And now you can see I can choose to add features. So maybe I'll make a polygon that links these. And I right-click in order to stop creating it. Oh, it doesn't look like my other attribute took hold. Well, there's something like what I made. It's not exactly what I made. That's all right. Okay, where do you find the Vermont map with tiles? Find the Vermont map with tiles. I'm not sure what you mean, Robert. Oh, you mean a map that shows the tile setup and what the names are. It's potentially going to be different for each data layer. Okay, so I think Robert's question is, whoops, if we are looking for data and it's tiled data, how do we find that map that shows us what the tiles are? So it's going to be different for different data. Examples would be, what else do we have besides contours? My mind is blanking on anything else, but in general, this is what you would do. So let's say you search for some data. When you click on download, it automatically takes you to a list like this, and you have no idea which one of these is what you want. At the top of that list, anytime you see a list like this on our website, at the top of that list, oh, not quite at the top, next to the top, you'll see a PDF, and that will be your index map. And then you just need to zoom in until you can really see what you're looking at and pick the tile that is covering the area that you're interested in. So then just remember that number, hit the back button, and then look for that number in this list and download it. Oops. Okay, my other question is, how does your road network data compare to Tiger data for Vermont? How does it compare? I don't honestly know. I haven't worked with the Tiger data much. All I can say is I'm assuming our data is better because it comes directly from the VTrans and 911. We actually have two sources of roads data. They're in the process of trying to harmonize them. But the 911 system and the Agency of Transportation both maintain roads data, and the main differences were just that E911 included private roads because obviously that would be important to emergency responders, whereas the Agency of Transportation didn't care so much about those, and then the Agency of Transportation maintained some attribute data that 911 wasn't as interested in. But like I said, they're working on improving them. So the Tiger data, I honestly don't know how it compares. I cannot remember whether they have coordinated with the Agency of Transportation in the most recent census, so I'm not sure. And if there are any other questions, I'd be happy to answer them. Trying to think if there was any other parting comment that I wanted to share. I don't think so. All right, well, I appreciate everyone's participation, and if you didn't hear at the beginning of the webinar, we do record and post all of our webinars, and they're posted at our YouTube page. You can get to the YouTube page by going to the front page of our website, vcgi.vermont.gov, and all the way over on the left, all the way to below the contact information, see Connect with Us, and there's a link to our YouTube page. And it looks like this, and you will see QGIS data acquisition and transformation appear here probably within a couple hours, but by tomorrow morning at the latest. So thank you very much, everybody. I'm going to sign off now. Oh, wait, maybe one more question. Sorry. So Reed says, in my current version of QGIS, you have to buy a license to view JP2. I don't think that's true of JP2. I never, so Reed is asking about an image format that much of our orthophoto imagery is provided in, JPEG 2000, and I don't think I've ever had a problem looking at JPEG 2000 in QGIS. But if you do, I definitely recommend upgrading to the newer version. It's not that different. It's not going to be harder to use, and it definitely doesn't have that issue. The Mr. Sid I don't know about, as he also asks about Mr. Sid compressed format. Okay, so Richard asks, is your road and address data tied directly to 911 or updated occasionally? Oh, updated occasionally, definitely. Yeah, we don't have a live connection to road and address data. That is data that's passed along to us periodically by VTrans and 911. Okay, so sorry. Now I really will say goodbye. I think those are the last questions. Thank you, everybody, and we will have this recording posted by tomorrow morning at the latest. Hope everyone has a good day.